This is pre-algebra or 7th grade math. This is the practice test number 5. Let's jump right in. All right, in the first problem, we're supposed to state if the first number is divisible by the second number. So how do we do our divisibility by 3 test? We add the digits. This 7 and 2 are going to turn into 7 plus 2. 7 plus 2 is 9. If this was a 2-digit number, I would go ahead and add the digits again and again and again. I'll show you what that looks like in number 78. But right now, you're either going to get one of 3 things. Or I guess you're looking for 3 things. Is the answer 3, 6, or 9? Because if so, the answer is yes. If it's anything else, then it's no. So this is a 9. 9 is divisible by 3, so it's 3 and 6. Those are all divisible by 3. Therefore, 72 is also divisible by 3. And then you answer here yes, and you'll box it. And then you can clearly see my work up here. All right, and I can check my work, right? Because it's right on, there's 2 pages here. It's going to be yes. I think I'm going to go through a speed round and just do everything without checking my work. You, the student, will check my work, and if I make a mistake, it's going to be extra credit. Log in your extra credit trackers when you see me next. All right, how do I do divisibility by 9 test? Again, you're going to add the digits. 7 and 8 we are going to add together. 7 plus 8 is 15, which you might not know. Okay, is 15 divisible by 9? Hopefully you do, but if not, you can keep doing it again. I can say 1 plus 5, and 1 plus 5 is 6, and you can say, darn, it's not 9. This number has to be 9. So if it was a 9, then it would be yes, but this is a 6, so the answer is unfortunately a sad face. No, it is not. All right, in number 3, divisibility by 6 is really asking 2 divisibility tests. Is it divisible by 3, and is it divisible by 2? Divisibility by 2 is the easiest. I'm going to start here. Divisibility by 2, I just look at the last digit. This last digit, and I'll go ahead and annotate this, is even. Therefore, you can check off 2. It is even, therefore we are divisible by 2. To check if it's divisible by 3, we do that same test that we're talking about up here where I add all the digits together. I can say 3 plus 7 plus 8. 3 plus 7 is 10. 10 plus 8 is 18. All right, then I do it again. 1 plus 8 for the 18, and that's going to be equal to 9. And again, the 3 numbers I'm looking for, the things that are divisible by 3, is this number a 3, 6, or 9? It is. It's a 9. 9 is divisible by 3. Therefore, 378 is also divisible by 3. So you can give yourself a check for 3. If you give yourself both a check for 3 and a check for 2, then you can also give yourself a check for 6. You can say, yes, it is indeed divisible by 6. All right, and 406 divisible by 2, that's nice and easy. Again, you just check that last digit. If that last digit is even, in this case it is, this is even, then you can say, yes, we are divisible by 2. And number 5, we are doing our properties of exponents. Remember that there is a hidden 1 here, and because we have the same base, which I'm calling the bottom, I guess, and these exponents, it doesn't matter what they are, because we have the same base and we are multiplying those bases together, we are going to add our exponents, and this is going to keep the same base. This base does not change, and then you do 1 plus 2 to get 3. Final answer, and box it. The amount of work that you need to show for this problem is very little. You just need to write the 1 there, and then you're showing all of your work. In number 6, again, we have the same base, 7 and 7, so we are now going to subtract these powers because we have division happening. When you do your subtraction, the shortcutty way of doing this is to look which of these exponents is more positive. Well, 4 is more positive, so that means that my answer is going to live in the bottom. My base of 7 is either going to be there or there, and the answer, the 7 is going to be in the bottom because the base has a higher, that the denominator has a higher exponent. That means there's nothing up here in the top, which means if there's nothing, you write a 1. All right, then because we're writing our answer in the bottom, I'm going to be doing bottom minus top. 4 minus the top, and the top is negative 4. So there is a double negative. When negatives kiss, they become positive, and this is now 1 over 7 to the power of 8 for my final answer, which I will then box. And number 7. A lot of people first saw this and said, yes, distribute the 4. You're right, you distribute the 4 into every single base, but there's only one base. For example, if I look at the next page, you can see that if I have like a 3 here, the 3 does distribute, let me zoom in here, the 3 does distribute to both the n and the 4. There are multiple bases down here. But in the problem that we're currently working on, there's only one base, so there's not really distribution that's happening here. The 4 simply is going to be multiplied by this negative 3. It is a multiplication because I have a power to a power, and I simply get 6 to the power of negative 12. Negative because there's one negative sign. When you multiply and divide, you just count the number of negatives. If it's an odd number of negatives, it's an odd. If it's an even number of negatives, it's positive. I think I said that right. I think I might have said odd twice, but I hope you get my point. We are not done because we have a negative exponent, which means I need to flip. Right now, this is the same thing as divided by 1. I'm going to flip this 6 to the power of negative 12 into the denominator, and this is going to be 6 to the power of positive 12 in the denominator. What's left over in this top? Nothing. So if there's nothing, you assume it's 1. You still have to have a fraction. And there's our final answer, which we will then box. And number 8, oh, lucky us, we got a power of 0. Check out the power of 0. Everything directly underneath the 0, namely that 2 and that 0, are going to be crossed off, and you basically ignore it. You kind of scribble it all out and say, it never existed. But I want to show my work, so I'm just going to do it like that. And then from here, I'm going to notice that I have the same base, and I have division, so I'm going to be doing subtraction. Knowing that I'm doing subtraction, I'm asking which of these powers in the numerator and denominator are the most positive, and the answer is 4 is the most positive, so my base of 2 is going to only live in the denominator, and there's going to be nothing up here, so if there's nothing, you just assume it's a 1. And then because our answer lives in the denominator, we're going to do bottom minus top. The bottom is 4, and we say minus the top, and the top is a negative 3. There is a double negative here, so my answer is going to be 1 over 2 to the power of, well, double negatives kiss, and 4 plus 3 is 7, so this is 2 to the power of 7. Final answer, and box it. In number 9, we have a lot of things going on. I first see that I have a power to a power. Again, I want to think about distributing, but there's only one base, so I'm just going to multiply these two together. 3 times 2 is 6, so this is going to be 3 to the power of 6, and I'm just going to rewrite this times 3 to the negative 1 over here. Nothing really happened yet. 3 to the power of negative 1. We could flip this 3 to the negative 1 into the denominator, but there's a faster way. I could just add these exponents right now and be done with it. I can go ahead and say that this is now equal to, there's an equal to here, this is equal to, keep the same base, and because we have multiplication happening, I'm going to be adding their exponents. 6 plus negative 1 is 5. Final answer, and box it. In number 10, oh yeah, check it out. I have a power of 0 here, which means everything underneath, and because there's parentheses, that's everything right here. Everything goes to 1. The denominator does not exist. That fraction doesn't exist. I only have this problem. The way that you annotate that in the work is you cross all of this out and say that is all 1, aka ignore it. So my new problem is really 3 to the negative 3 times 3 to the power of 4. That is my problem. From here, because I have the same base and I'm multiplying, I'm going to add the exponents. Negative 3 plus 4 is going to be 1, so this is going to be 3 to the power of 1. While this will get you full points on a quiz, test, or homework check, you typically don't write this power of 1, and you just say this is going to be 3 for my final answer, and we'll box that. In number 11, I have a bunch of things going on. I'm first looking at the coefficients. I have a 7 and a 3 with multiplication, and I just multiply. 7 times 3. 7 times 3 is 21. Now I have the same base, p and p, so I'm going to add their exponents due to the multiplication happening in their bases. So 4 plus 2 is 6, and this is p to the power of 6. Please do not forget that you always have to have a variable, unless that variable is to the power of 0, in which case you can cancel it out, right? There's our final answer, which we will then box. I'm noticing I'm not really showing very much work for this one, but I'm still going to be considering this a 4-pointer. How could I show my work? I'm guessing the way that I could show my work is I could do some intermediate step like 21p to the power of 4 plus 2. Now I'm showing my work. Hooray. All right. In number 12, I'm seeing two different parts. I see this left-hand side, 8 divided by 6, and this right-hand side where I have variables. Let's work on this left-hand side first, 8 over 6. If I had the fraction 8 over 6, I could reduce that fraction by dividing both the numerator and denominator by 2. If I do that, my new problem becomes 4 over 3. That is indeed our first step over here. We get 4/3. Extend this bar over a little bit. Okay, now that I'm dealing with the variables, both of them have the same base, so I'm going to use properties of exponents, and I ask myself, due to the division, I know I'm going to be doing subtraction, which of these two exponents is more positive? And it's a little bit tricky with negatives, but negative 3 is a little bit more positive than negative 4, so my answer is going to live in the more positive area, that numerator. So v lives up here, which means no variable lives down here. Now I'm going to do top minus bottom. I'm going to be doing negative 3 minus and then the negative 4. I do have a double negative happening here, so negatives kiss and become positive. And I need to do negative 3 plus 4, which is just 1. So I have now 4v to the power of 1 all over 3. Again, this will get you full points on a homework check, quiz, or test, but this power of 1 is more simplified as writing just a v, so this is 4v over 3. And that is my final answer. I'm not sure in the back, but it might have a 4/3 with a v out here. Both of these are valid answers. Typically, I would guess that the answer key will probably do that one. And that's the first page. We're on to the second page of 2 for our practice test. This is a practice test, right? I'm just making sure I'm talking about the right thing. Yes, this is a practice test. All right, so in number 13, I have two bases on the inside. I have a 6 and a k. So that means this -2, I'm going to do this in ink, -2 is being distributed to both the k and to the 6. When I do that, I'm going to get a 6 to the -2 and a k to the power of 3 also to the -2. I've now done my distribution. From here, I'm going to simplify as much as possible. I'm noticing a power to a power means multiply, so this is now going to be 6 to the -2, k to the multiply 3 times -2 is -6. All right, and then from here, I'm only able to switch them. I originally have, this is being divided by 1. I'm going to switch the side that this entire base and exponent are going to be on. This is going to be in the denominator. This is going to be in the denominator. We're going to flip. If I flip both of them down, what's left over in the top? Nothing. And if it's nothing, you assume it's going to be 1. So 1 is left in the top. In the bottom, this is now 6 to the, not to the -2, but +2. And this is k, not to the -6, but +6. And I mean, I'm basically done at that point. I would give you full points if you just write this on a quiz, test, or homework check, but we are doing 1 over 36 k to the power of 6 in order to prove that you know how to take higher powers in our test. So final answer and box it. Number 14, I'm first looking for coefficients. I see a 4, 1, and 1, so I'm just going to leave it 4 on the top. I've dealt with all my coefficients. Excellent. Now, I can combine this p and this p in the top, and I'll worry about you later in the denominator. And I'm just going to, because of the multiplication, I'm going to be adding 3 and 2. I'm going to get 5. This is p to the power of 5 in the numerator. The denominator, we're not going to touch, it's still p. Technically, that's p to the power of 1. So from here, I can now do my division. This p to the power of 5 divided by p, these have the same bases, and we're doing division, so we're doing subtraction. When I do subtraction, I have to figure out which one is more positive, the 5 or the 1. And clearly the 5 is more positive, it's bigger, so I'm going to have, leave the 4. The answer is going to be in the top with nothing in the denominator. If there's nothing in the denominator, you don't write anything in the denominator. And I'm going to do, because my answer is in the top minus bottom for our power. Top minus bottom is going to be 5 minus 1. This is going to be 4p to the power of 4 for our final answer. We're on to number 15. All right, remember, we have two different bases, so this 3 is going to be distributed twice. The 3 is going to be, I want to do this in a slightly different color so I don't see the black on the black. 3 goes to the n and to the 4. Same thing, this -3 only goes once to the n, so there's not really distribution happening there. So what do we have? We have a 4 to the power of 3 and an n cubed also to the power of 3. I can call that n cubed cubed or n to the power of 3 to the power of 3. It doesn't really matter how you say it out loud. And then over here I have an n to the power of, well, power to a power means multiply. Negative times a negative is a positive, and a 3 times a 3 is a 9. All right, from here I already said an n to the power of 3 to the power of 3 is 9, n to the power of 9 here, and 4 cubed. How do I do 4 cubed? So I'm worried about you. Let's do you off to the side. So 4 cubed is the same thing as 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is, there's going to be a 4 right there, and I'm going to get 64. All right. So 64 goes out front, and I have 2 of these n to the power of 9s. Again, you went right there, you went right there. So now that I'm multiplying the bases, I'm going to add these exponents. 9 plus 9 is 18, so I'm going to get 64 n to the power of 18 for my final answer, which I will then box. On to number 16. In number 16, I have a bunch of things that I could do. A lot of people would probably see the 0 and cross it off, probably distribute the -1 next. I like that, crossing off the 0. That's my favorite thing to do, is get the problem and make it easier. So this is going to be all crossed off, and I'm going to get, ooh, look at this. This also crosses off. Check it out. 2 and 2, those are the same thing. I can just cross these off right now. That's the equivalent of saying this. You can alternatively say 2 divided by 2 is a fraction, and you can reduce by dividing the top and bottom by 2, and you get 1 over 1, which is the same thing of saying there wasn't anything there. So in this problem, I'm going to just cross off the 2, cross off the 2, and I'm going to get the new problem. N squared, nothing in the bottom. Look. Cross, cross, there was nothing in the bottom. That denominator is nothing, so I just have that n squared in the top, and that's to the power of -1. Look how easy our problems become. Now I just multiply. Power to a power means multiply. 2 times -1 is -2, and this is n to the power of -2. Oh, I thought I was going to be done, but we have a negative power, which means I need to flip it, and this is now going to be 1 over n squared for my final answer. Oh man, we're really close to being done, right? I don't have anything else over here. We got a little bit more to do. All right, in number 17, I'm going to simplify the inside of this parentheses as much as possible. Look, I have a 2 and a 2. Let's multiply those together first. So I'm going to get 4, and then let's go ahead and, okay, I have multiplication happening. Base and base are the same. That means I get to add these exponents, positive 2 and negative 3, add together to get a negative 1. This is n to the negative 1. That denominator hasn't moved. It's still n squared. I'm going to rewrite you. This is still all to the power of 2. I haven't forgot the power of 2 either. From here, I can still simplify because these n's can be simplified to just one n, which is more positive. This 2 is more positive than that negative 1. So my answer is going to be in the denominator. This is going to be 4 stays on the top, but that n is only going to live in the denominator, and I'm going to do bottom minus top because our answer is in the bottom. So it's going to be 2 minus negative 1, and then still all of this is to the power of 2. From here, I'm going to leave that 4, and this is now n to the power of, again, double negatives kiss, they become positive. This is n to the power of 2 plus 1. This is n to the power of 3, and then technically this is still all to the power of 2. I have not distributed that 2. I'm waiting till the very end, and I'll distribute you when it's as easy as possible. Now, it is as easy as possible. So the 2 is going to come up to this 4, and then down to this 3, and I'm going to get 4 squared over n to the power of 3 to the power of 2. So from here, that's going to be 16 over n to the power of, you multiply power to a power. So this is going to be 3 times 2, which is 6. And I get my final answer. Again, you didn't have to solve it like me, but you should still get the same answer. Unless I made a mistake, in which case you will get some extra credit. Oh, I gave you such a nice problem. Look at that. 0, and then everything under the 0 is in parentheses, which means everything in the top is gone. Our new problem just has a 1 in the top. Whew, that was nice to you, wasn't I? What about the denominator? Well, let's look at all the coefficients. I have a 3 and a 1, so just a 3. All right, so 3 for the coefficient. Let's look at all the x's. Because I'm having multiplication, I'm just going to add 3 plus, well, that's technically a hidden 1 right here. Let me write that in a different color so it pops out. I'm going to add this 3 plus 1 to get a power of 4. And then what about our y's? Y's, I'm going to do a power, I'm just adding again. 4 plus 2 is 6, y to the power of 6, and there are no negatives. That's a positive, that's a positive. I'm done. That was actually a really easy problem, and the only work that I showed was this power of 1 here. Oh, I guess I should show my work saying all of you went to 1. Now I've showed all my work. All right. And then we get our scientific notation questions. We're almost there. Number 19. Convert to scientific notation. Right now, the decimal place is technically at the far right. I'm going to move it 1, 2, 3, 4. So this is going to be 3 times 10 to the power of 4. Notice that, and I like pointing this out, this number was big and it got small. It got smaller. And this decimal, this was technically times 10 to the 0. I'm going to go ahead and write that as well. Technically, that power went from 0 to 4, which got bigger. You should always have this balance of small and big or big and small. They should always be opposites of each other. So I know that I'm correct. I'll go ahead and box that final answer. And the showing of the work in this case is counting the bounces and getting all the work done here correct. Number 20. Again, I'm going to move the decimal place until it's right behind a number other than 0. So 1, 2. And this is now 5 with nothing behind it. And this is going to be times 10 to the power of. Okay, well, again, we got, and I'll do my arrows in a different color, we got bigger here. Which means that this number, it used to be times 10 to the power of 0. Now it's going to be times 10 to the power of. This has to get smaller. Because this number over here got bigger, right? If this number is getting smaller, I need to be subtracting. I'm going to be subtracting 2. Why 2? Because there are 2 jumps. So I'm going to be doing 0 minus 2, which is just negative 2. And there's my final answer, 5 times 10 to the negative 2. In number 21, now we're going backwards into standard notation. Now we're trying to get this power of 2 to the power of 0. So I'm going to go ahead and preemptively write times 10 to the power of 0 to help explain, and I'll simplify it in a sec. So if this number goes from 2 to 0, that number is getting smaller, which means the number over here needs to be getting bigger. If this number is getting bigger, like 0.4, that's 0.4. That's getting smaller. That's going the wrong way. My decimal place was right here at the right. The decimal place needs to be moving to the right. How many places? 2 places. So we're going to go 1, 2, and I'm going to get 400. Why 2 zeros? Because the zeros filled those empty spots. So my final answer is going to be 400. Final answer, box it. Forgot my R for the smaller. Number 22. Again, kind of the same thing. You need to get this times 10 to the power of 0. This power of negative 3 went to 0, which means you got bigger because you're adding 3 to it, right? That means we're getting bigger. If we're getting bigger over there, this number over here needs to be getting smaller. If I'm getting smaller, that means I'm moving the decimal to the left. I'm moving it 1, 2, 3 to the left, which means I have a 1, 2 zeros in front of the 5. I have 1, 2 zeros in front of the 5, the decimal place up there, of course, 5, 1, 3, and there's my final answer. It's going to be 0.00513. Do you need that leading 0 right here? No, but textbooks do it to make sure that people know that it is a decimal. And there's our final answer. All right. Last 2 questions, we're almost there. All right, the first thing that I see, common base, common base. I'm gonna go ahead and add those powers together because we're multiplying their bases. So again, this is no symbol here, so you assume it's multiplication. I can add 3 plus 2 to get 10 to the power of 5. All right, I need to do 6.73 times 7.58, and I do tell you it's required to use a calculator. You could do this by hand if you wanted to. I'm gonna use a calculator because I like going fast. Do I have a calculator open? Nope. That picture, by the way, I was looking up vaping information because we had or smoking information. I was trying to see if the speaker was spitting facts or spitting lies, and they were facts. So over here, let's go ahead and, okay, how do I do this? I want to have you split view, and I want to have you on the other split view, please. There we go. All right, and I'm going to have you a quarter of the way. Now I can start seeing. So I'm going to type in 6.73 times 7.58. There we go. And I get, let's zoom in here so I can actually see what I'm writing. This is going to be in pen blue ink. We're going to say 51.0134, which is not in scientific notation. So to turn it into scientific notation, I need to move u to the left, u decimal point to the left. So it's going to be 5.10134 times 10 to the power of, okay, let's do the brief analysis. This number over here is going to do what if this number over here got smaller? If this number got smaller, this number has to get bigger. So by how many decimal places? By 1. So it's going to be 10 to the power of 6. There's my final answer, which could have been rounded. So I do want to round it. This is going to be 5.101. Again, I round to that 3rd decimal place. Notice that the number that comes next after the 1 is a 3, which is 5 or less. So it's going to be 5.101. And I still have, going back to the pen, times 10 to the power of 6 for my final answer, which I will then box. We are on our last question. Here we go. All right. I'm going to look at you, 10 and 10, same base, so I'm going to add their exponents. 4 plus -2 is 2. So I have times 10 to the power of 2. Now, let's go ahead and type in 1.96. I didn't get my point, so backspace. 1.96 times 7.9. I don't know what I'm doing there. 7.9. And I get 15.484, which is not in scientific notation. I need to move the decimal place 1 to the left, which means I'm going to get 1.5484 times, okay, do the analysis over here. This number got smaller. That means this number over here needs to get bigger. So by how many decimal places? By 1 decimal places. So it's going to be times 10 to the power of 3. Let's go ahead and round correctly. This is going to be 1.548. Again, we keep this number 8, and because the number after it is less than 5. If this had been a 5, it would go up, 6 would go up, and this would change into a 9, but that's not the case. So I can just continue writing the problem. This is still times 10 to the power of 3. Final answer, and box it. And that concludes all of our practice tests for whatever unit we're on. It looks like unit 5. So I hope that I made some mistakes. I didn't intentionally try to, but if you caught any mistakes, please log them. Thanks for watching this video, and I'll see you guys later.